last class, we have discussed the wave equation. The wave equation is this. Wave equation is A cos omega t plus phi naught. This is the wave equation. X is A cos omega t plus phi naught. This one more term. Kx minus omega t plus phi naught. And instead of x, I'm using y. This x basically represents the direction in which your wave propagate. The direction in which your wave is traveling. Your wave is traveling along positive x-axis or negative x-axis given by this way. This basically shows the direction in which your medium is oscillating. When we usually say y, we mean that the particles of the medium are oscillating along y-axis, and this is basically the direction along which your wave is traveling. In waves, we have two types of displacement. One is the displacement of wave, another is the displacement of the particles of the medium. So this x here represents the displacement of wave, the direction in which you say, if we are talking about sound waves, then this x tells you in which direction your sound wave is traveling. But y will tell you the direction in which your particles of the medium are oscillating. So now if you have two displacements, that will mean you will have two velocities also. Y is A cos kx minus omega t plus phi. Instead of cos, you can always use sine as the same thing. So you have two displacements, so you have two types of velocity. One is the particle velocity, another is the wave velocity. So let's discuss them one by one. So the first one is the particle velocity. Particle velocity means velocity with which the particles oscillate. So we represent particle velocity with Vp. Particle velocity is dy over dt. When you differentiate it, this is d over dt of it's a cos kx minus omega t plus phi naught. When you differentiate it, see this a is a constant. You can take this constant a outside. When you differentiate cos, the differentiation of cos is minus of sine kx minus omega t plus phi naught. But instead of this t, you also have one this omega. So this minus omega will come outside, and your particle velocity will comes out to be, this is omega a sine kx minus omega t plus phi naught. This expression of particle velocity will depend which expression of displacement you are using. Instead of cos, if you are using the expression of displacement in terms of sine, then your particle velocity will come in terms of cos. That's particle velocity. After particle velocity, you can have particle acceleration, the acceleration with which your particles oscillate. So you can have particle acceleration, the acceleration with which the particles of your medium oscillates. So your particle acceleration is just rate of change d over dt of particle velocity. So this is d over dt of particle velocity, which is omega a sine kx minus omega t plus phi naught. So the particle acceleration is omega a is constant. When you differentiate sine, you get cos. You get cos kx minus omega t plus phi naught. And instead of with t, you are getting a minus of omega. So take this minus of omega outside. So your particle acceleration will comes out to be minus of omega square a cos kx minus omega t plus phi. If you want, you can write this a cos omega t plus phi naught in terms of x. You can write that your a cos kx minus omega t plus phi naught is equal to x. So the particle acceleration will comes out to be it's minus of omega square x. If you look at these equations very carefully, these equations are almost the same what you got in SHM. You got the same equation of acceleration is SHM. You get these type of equations for velocity in SHM. So basically, the particles of the medium are oscillating simple harmonically. That's why the equations of velocity and acceleration of the particle matches with that of SHM, what you have done in SHM. So that is particle velocity and particle acceleration. There is one more velocity which is known as wave velocity. There is one more velocity which is known as wave velocity. So what is wave velocity? It is the velocity with which the wave travels. And wave velocity is simply frequency multiplied by wavelength. This is wave velocity, frequency into wavelength. If you want, you can convert this thing in terms of omega and k. If you want, you can convert this in terms of omega and k. So you can say that your v is nu, you can write it's omega by 2 pi. So this k is 2 pi by lambda, it's lambda is 2 pi by k. So instead of lambda, you can write 2 pi by k. So this will get cancelled out. The same thing, I'm just converting nu because omega is 2 pi nu. So instead of nu, I'm writing omega by 2i. Instead of lambda, I'm writing 2 pi by k. So your v comes out to be omega by k now. So this is the wave velocity. This is the velocity with which your wave travels. Like this is the velocity with which your sound wave is traveling. And earlier it was the velocity and acceleration with which the particles of the medium were oscillating. Okay, after particle velocity, particle acceleration, wave velocity, the next is the reflection of wave. The next is the reflection of wave. This is the same reflection that you must have done in optics, in ray optics in class 10th. The reflection of light, laws of reflection, angle of incidence is equal to angle of reflection. Okay, Noor, I will finish it up for up to maybe 7th or 8th Feb. I will finish everything. After this topic, I'm just left with thermodynamics and KTG. So I'm sure I'll finish it by 6th or 7th Feb. Reflection of wave. So reflection of wave in class 10th, you have done reflection using geometry. Like angle of incidence is equal to angle of reflection. But now you will do reflection of wave using the equations. So your wave can get reflected from a medium by two types of boundaries. Your wave can be reflected by a closed boundary. Your wave can get reflected from a closed boundary, or your wave can get reflected from an open boundary. First, see how the reflection from a closed boundary takes place in a wave. See, this is a closed boundary. This is a string. This is the closed boundary. You take this string, attach this string with the closed boundary. You send a wave here. This wave travels here. This is traveling along positive x-axis. It strikes the closed boundary. This is your incident wave. Huh? This wave is your incident wave. This is your incident wave. It strikes the closed boundary, then it reflects. Then it reflects back and travels in the opposite direction. So this is your reflected wave. Reflected wave. When your wave gets reflected from the closed boundary, its direction will change. Earlier it was traveling along positive x-axis, but now it will travel along negative x-axis. And also the phase changes. Phase means earlier it was crust, but after reflection, this crust becomes trough. So that at the boundary, they cancel out each other. So when you incident a wave at a closed boundary, its direction will change, which is very natural. If incident wave was traveling along positive x-axis, reflected wave will travel along negative x-axis. But along with this, its phase will also change, means crust will convert into trough. Crust and trough have a phase difference of pi. See, this wave, this is your wave. If I start writing phase, this angle is 0. I call this as pi by 2. I call this as pi. I call this as 3 pi by 2. And I say this is 2 pi. This point and this point have a phase difference of pi. Crust and trough have a phase difference of pi. This is important. You should remember this. Crust and trough have phase difference of pi. Remember this thing. So in a closed boundary, crust gets converted in the term of trough. So this is the equation of incident wave, which is, let's say this is a sine kx minus omega t. This is incident wave. This is equation of incident wave. The equation of reflected wave is,
A sine
yes,
k
very good.
plus omega
Reflected
t.
wave is a sine, good, kx plus omega t. There is one more minor change. Is there any
Plus
change in
one.
phase? Yes. How much? Pi. So you will write a pi. Because the reflection is from the closed boundary, so the direction of wave will change. Along with the direction of wave, the phase will change. So this is your reflected wave, a sine kx plus omega t. So this was about closed boundary. Examples of closed boundaries are reflection of string from wall, closed organ pipe. These are few examples of reflection from a closed boundary. But instead of a closed boundary, if you have an open boundary, if wave is reflecting from an open boundary, one example of open boundary is open organ pipe, like flute. In case of a flute, rays reflect or your waves reflect from an open boundary. For an open boundary, if this is the equation of incident wave, I'm just, so this is your string. This is your string. Your wave is reflecting from an open boundary. So open boundary means this is crust, this is crust, this is crust. This crust is traveling to the positive direction of x-axis. After reflection, this will return as a crust only. No change in phase. So if I write equation of incident wave, that equation is this: yi is a sine kx minus omega t. For reflected wave, you can say that this is a sine, it's kx plus omega t. There is no change in phase. When the reflection is from an open boundary, there is no change in phase. The change in phase is only if reflection is from a closed boundary. Superposition principle. So superposition principle simply tells about the combination of waves. Say you have a number of waves traveling in a medium. Maybe say you have some 5 or 6 speakers. From every speaker, a wave is coming. The wave coming from these individual speakers will combine, and after combination they will give a resultant wave. So now you have to calculate how that resultant wave can be calculated. Wave can be calculated means how the equation of that wave can be calculated. Say you take 2 speakers, some sound waves are coming from both the speakers. Those 2 sound waves will combine, and after combination they will make a single wave, a single sound wave. Now you have to write the equation of that single sound wave. How to write the equation of that single sound wave? The superposition principle says whenever a number of waves traveling through a medium superimpose to give a resultant wave. Displacement of resultant wave, displacement of resultant wave is sum of displacement of individual waves. Is sum of displacement of individual waves. That means if the displacements of the individual waves are y1, y2, so the displacement of the resultant wave is just the sum of them, y1 plus y2 up to y. This is superposition principle. So that was superposition principle. The next thing is we have some applications of superposition principle. Applications of superposition principle. Superposition principle. So the applications of superposition principle includes the one is interference. Interference is not given in NCRT, so I'm not discussing it. The next 2 applications, the one is standing wave and another is beat. This standing interference is not a part of your syllabus, so I'm not discussing interference. Standing wave is deleted portion, and there is, after application of superposition principle, there is one topic which is known as Doppler's effect. This is also a part of deleted portion. These are very important portions of waves, Doppler's effect, standing wave, and beat, but these are in the deleted portion.